So we continue our discussion about primitive functions to complete what we have started actually. So let us do some warm-up with an example here. So example number one, determine a primitive. So I have emphasized on the article a, primitive functions of the function h. So this is a misunderstood. That should be a function. So determine a primitive function of the function h in terms of the functions f and g. Okay, so the goal of this exercise or this example is actually to improve your skills about some guesswork when it comes to primitive functions. So you remember, even though we started with a little bit of guesswork, but we were able to find the primitive functions for those functions which was not easy to guess its primitive function. Yes. So here I want to continue that idea. So for example, I'm asking you, by looking at the structure of this function on the right hand side, can you guess what would be a primitive function for the function h of x? For example, if you remember, I asked you what is a primitive function of f prime of x. So a primitive function of a function means a function whose derivative is here. Of course, this is very trivial, so a primitive function for f prime of x is just simply f of x, a primitive function of that. If I ask you what is a primitive function for f double prime of x, then of course you answer that's f prime of x, because the derivative of f prime is f double prime, and so forth, yes? And we also learned about two rules, that if I ask you what is the primitive function of f plus g, you can write primitive of f plus primitive of g. We also learned that primitive of a constant multiplied by a function is c times the primitive of that function. But we also learned that, be careful, that this is no longer correct, that the primitive function of the product is the primitive function of f times primitive function of g. No, this is not correct. Okay, now I want to improve a little bit of guesswork. So can you tell me, what is a primitive function for for g? So let me write number one for h. Do you have any idea?
For h, f of x times
Exactly, because I am asking you, what is a primitive function? What is a primitive function for h of x? So it means that if I am interested in finding a primitive function for h of x, of course, then it means that I am asking you, give me a function whose derivative is equal to this one. But I have intentionally written something that you can immediately understand. It's a product rule, yes? So then the answer to this question is simply f of x times g of x. Since the derivative of f of x times g of x is equal to the derivative of the first one times the second one plus the first one times the derivative of the second one, which is exactly the function of f of x. Of course, I use this notation for all primitive functions. In principle, I should have this c at the end, but here I have emphasized, here I'm just abusing the notation a little bit. So in principle, I use this PR for all cases, so I have in principle to write a c here. But except for that, everything is right. So I am asking you, give me a function whose derivative is equal to this, and you just gave it to me. That function is f of x times g of x. Okay, can you do this guesswork? So for these two, guessworks are easy, but this is a little bit more complicated. So what do you think about the guesswork here? So number two.
Is it ln f of x?
Exactly, thank you. So primitive function of f prime of x over f of x is exactly as you said, ln of f of x. And then hopefully there is no need for more explanations, because if you remember, we learned that ln of u, where u is a function of x, is u prime over u using the chain rule. So that's exactly the case. So here, primitive function of f prime over f is ln of f of x. But the other one is a little bit more subtle to guess. Okay, any ideas? Okay, so this is a little bit technical, okay, so it might need a little bit of experience. So first of all, let me change the form of this function. I will do this, but you need to be patient to see why this works, okay, and then hopefully you get some experience so that you can use this experience for future problems, okay. So what I do, let me just repeat everything here. What I do, I would do this. I would write f of x g double prime of x. But what I do, I would write plus f prime of x g prime of x, and then I subtract the same thing, f prime of x g prime of x, and then I have another last term which was in the problem from the beginning. First of all, I want you to understand that this equality is valid still, yes? Because this expression that I have added is exactly equal to the same expression that I have subtracted. So in principle, these two can go away, and what is left for me is this, which is the first term, minus this, which is exactly this term. So I haven't done any changes to this. I have added just fancy term here, and I subtracted this. But why do you think this is useful? Now you might have some clues why this is useful.
Because by the law of multiplicity, rearrange them so that you group first two in one, last two.
No, you need to be very specific.
Like you put brackets around them.
Okay, so if I put brackets around them, then what? Yeah, I put a bracket around here, then I can put a bracket around here.
The second is a plus sign instead, so then you can use the first rule that we used.
Okay, so can you tell me what is the
Product.
What is a primitive function for this part?
I think it would be, let's see, yeah, it should be f of x times g prime of x, I think.
Yes, thank you. That's correct. Yes, so you are completely right. So we continue like this, as you said. I put them in a pair of brackets. So here I would write it as f of x times g double prime of x plus f prime of x g prime of x. Between the next two terms, I factor a negative sign out, so it becomes f prime of x g prime of x positive f double prime of x g of x. Okay, but now if you actually broaden your point of view, you see that this is exactly again the product rule. But here the product rule was the product of functions f and g. Here this is the product rule between function f and g prime. So let me write it down and then I will explain it again. So I would write it as f of g multiplied by g prime of x. Then I will take a prime out of it, yes? Let me try to motivate why this is correct. First of all, you want to differentiate a product. This is a product. So what is the product rule? It tells you differentiate the first one and multiply it by the second one itself. When you differentiate the first one, it becomes f prime, and when you multiply it by the second one, it becomes f prime dot g prime, which is here. That's correct. And then what you do, you write the first one, multiply by the derivative of the second one. But the second one already has a derivative sign, so if you differentiate it once more, it becomes f g double prime. And this f times g double prime is this term. So hopefully you agree with me, instead of writing this, I can compactly write that. Okay, and then for the same reason, hopefully now it's clear that the same strategy will work on the other side, but of course this would be f prime x times g of x, totally prime. Yes? Why is that? Again, let us repeat it. This is a product. I want to differentiate it, so it becomes the derivative of the first one, but it becomes f double prime times the second one, plus the first one times the derivative of the second one. And what you see here is exactly this combination. This is the first term, and this is this term. Okay, so now everything becomes clear. My goal is to find a primitive function for h of x. But I realize that I can rearrange h of x in this specific form, so it becomes primitive function of this combination. Yes, so that is the primitive function. But we learned a rule. I have two functions subtracted, and I want to find a primitive function. So it becomes a primitive function for the first one minus primitive function of the second one. Yes? But now tell me, if I ask you what is this one, what is your answer?
The f of x times the g prime of x.
Exactly, because this is a prime here. I am asking you, give me a function so that when I differentiate, it becomes this function. It is clear, if you give me this, when I differentiate it, it becomes this package. So this becomes exactly f of x times g prime of x, and for the same reason the other one is f prime of x times g of x. So this is the answer to this problem. Okay, and if you don't believe, I think this is a straightforward exercise that you can start doing this using two product rules, simplify them, you immediately see that you will get this back. So this exercise was a good exercise, especially the first two cases, which were obvious. I want you to sharpen your eyes so that you can immediately detect this pattern, so that you can go in the reverse direction. So that is an important skill when it comes to integration and finding primitive functions. Any questions? Okay, so now let us go to the next example. So if you remember, I think I was in the lesson, so I don't have those notes here with me. I was in the class, so okay, so let me just do it like this. Let me, oops, what happened? Let me, I told you that when it comes to primitive functions, we have three articles: all primitive functions, a primitive function, and the primitive function. Yes? About all, I told you that you have to keep c at the end. When I say a primitive function, it means that up to you what value you choose for the constant of integration c. Of course, the simplest possible case is to choose c equal to 0. So this is why we say that we don't write it. But in principle, it means that we have chosen it to be equal to 0. And when it comes to the primitive function, which is the topic of this one, it means that there should be an extra piece of information in the problem so that you can use that extra piece of information to fine-tune the exact value of the constant of integration c. Okay, so let me do this one for you, because if I remember, I didn't give you any examples of this type before. So if I want to solve this problem, determine the derivative function, primitive function capital F of the function little f with this rule, such that f at the Euler number e becomes equal to 2. So it is clear what to do, yes? What I have to do is to find all primitive functions first. So I would write capital F of x is all primitive functions. So, but you hopefully remember what is a primitive function for this? That's a constant. So I would write 4 multiplied by x to the power of 3 follows that simple rule. It becomes 1 over 4 x to the power of 4. But if you remember, this is the Math 4 lesson. So 3 over x can be interpreted as 3 times 1 over x. But 1 over x, with what we learned in Math 4, a primitive function for that is equal to ln of x. And I have a factor of 3, so it becomes negative 3 ln of x. But I have to keep the constant for the time being. Let me simplify the function. 4 and 4 are gone. So then I will have this plus c. But this is not the answer to the problem. I have to employ this extra piece of information to find the exact value of c. So what does it mean? It means that it is mentioned that f of e is equal to 2. So what it means that if I replace x with e, the answer is supposed to be 2. So this means that e to the power of 4 minus 3 ln of e plus the capital C is supposed to be equal to 2. And then I have to find c from this. But of course, hopefully you remember ln of e is just 1, so it becomes minus 3, and I move everything to the right in order to find c. So c becomes equal to 2 minus e4 plus 3, which is 5 minus e4. But what you have to write as the answer is you have to put this value for c back into this function, and that is then your answer. So f of x is equal to x to the power of 4 minus 3 ln of x. Instead of c, I put plus 5 minus e4. So this is when it comes to the primitive function. They cannot ask you about the primitive function unless they provide you with extra piece of information, so that you can use that extra piece of information to find this, to find that value. For example, if I want to give you another example, just cook up another example here. Let me change my color. For example, I can say that so determine let us keep it like this. Yeah, I will give you that example later. Okay, so hopefully you understand when it comes to the primitive function how you have to employ that extra piece of information. So now I would say that I will give you an example here. So if you don't mind, please make a screenshot so that I can use my iPad to fix the other pages and then start working on them. Yes? So let me see. I just put it here momentarily. Sorry, there was also a misprint. So I had written f of x, but I have given you this in terms of t. Okay, now let me start solving these problems because I want to also teach the new lesson. Hopefully you know what to do here, yes? So, number 1, if I want to find all primitive functions of this function, I need to change the form of the function, yes? And I think these are very simple ones, so let me just do them quickly. So f of x is equal to 2 divided by x to the power of 1/3, but then I can bring this up, it becomes x to the power of minus 1/3, yes? And then of course immediately I can use the famous formula, f of x becomes equal to 2, and then I would write multiplied by 1 over minus a third, and then please interrupt me if you think that there is something that you don't understand, okay? Mainly you should have the table in front of you so that you can see which formula I am using, because it has mentioned that I need to find all of them, so I put a capital C at the end. But if you calculate this, it becomes positive 2 over 3. It becomes 3 over 2. 2 and 2 are cancelled, so 3 is left. So capital F of x is 3. And x to the power of minus a third plus 1, it becomes 2 over 3, and then I have positive c at the end. So that would be the answer to this problem. Yes, any questions here? If you want to, I can write the formulas here. So the formulas that I am using are these formulas. So if I have little f, and then I have capital F, if I have x to power a, do you remember? It becomes 1 over a plus 1, x to power 1, a plus 1. If it is 1 over x, this is working if a is not equal to minus 1. And this becomes ln of x, and this is working if x is positive. Yes? And then of course, there is another formula that you need to know. If I have the mth root of some a to power n, this can be written as a fraction a to the power of n over m. So these are the formulas mainly that I am using for these problems. Yes? So number two, first of all, you see that this function is not in a form that I can use these formulas. So if you remember from what I told you in the previous session, I need to separate them. So what I do, I would write x to the 4 divided by x to the 3, and then I will have 5x divided by x to the 3, and then I will have 1 over x to the power of 3. But simplification of the first one gives me x. The next one gives me 1 over x squared. But I am supposed to solve it, so I bring it up. It becomes plus 5x to the power of negative 2. And the other one, 1 over x to the 3, it becomes x to the power of negative 3. And then what I do, I take a primitive function. So a primitive function now becomes, all of them, I will use this, for all of them I will use only the first one, because all of them are of that form. Here the power is 1, which is not minus 1. Here the power is negative 2, which satisfies this condition. The same for minus 3. So the primitive function of x becomes simply 1 over 2x squared. The primitive function, the other one, becomes minus 5x to the power of minus 1. The other one becomes minus 1 over 2 x to power minus 2 plus a constant. Yes? So let me just explain if you don't understand. For 5x to power minus 2, I put 5 aside. I wrote 1 over minus 2 plus 1, x to power minus 2 plus 1. But minus 2 plus 1 is minus 1. 1 divided by minus 1 is minus 1, multiplied by 5 is negative 5. So this is why I wrote it quickly, negative 5. And in the numerator, minus 2 plus 1 is actually minus 1. And I did the same thing for here, so you can just confirm that. But if you don't understand, please let me know. So number 3, again, this is a function. I don't have the direct formula for this function in my table, so I need to change the form. But this is easy, yes? Because then the function f of x can be written as 1 over 2x to power 4 is nothing except 16x to the power of 4. This can be assumed to be 1 over 16 multiplied by 1 over x4. But this means that 1 over 16x to the power of minus 4. Now this is exactly in the right combination that I want, so I can immediately find the primitive function. So it becomes 1 over 16 multiplied by 1 over minus 3 x to the power of minus 3 plus a constant. So let me simplify that. So capital F of x is actually equal to minus 1 over 48 x to power minus 3. There is no necessity to simplify that, but if you want, you can just put it back into the denominator and make it with positive power, yes? This is not mandatory, of course, you can just stop in the previous step. Yes, so that is the answer to this one. The answer to the previous one was this. Yes? Okay, so we go to number 4. So if you don't mind, let me solve number 4 on the other page. So number 4 is the same story. First of all, I changed the variable to t, so that you don't think that it has to be all the time x. And then you need to simplify this. So again, the idea hopefully is clear. So number 4, what I do is this. I will separate them first. So it becomes 2 to the power of t squared divided by, instead of a square root of t, I put 1 t over t to the power of 1/2. Then I will have 4t to the power of minus a half divided by, again, in the denominator I can write this, and finally the same for the last one. And then I will start simplifying. For example, the first one gives 2 t to the power of 2 divided by t to the power of 1/2. It becomes t to the power of 2 minus a half. I write the same base, I subtract the exponents. So it becomes t to the power of 3 over 2. Yes? So this becomes t 3 over 2. But the next one you need to be careful. If I simplify, so it becomes t to the power of, I will write and clean it, okay? So if you want, I can write it here. T to the power of minus a half divided by t to the power of 1/2. So it becomes t to the power of minus a half minus a half. So it becomes t to the power of minus 1. Okay? But if I go to the previous page, you see that this formula works all the time except a equal to minus 1. And that's exactly happening here. So this is negative 1. When it becomes negative 1, you need to interpret it as 1 over t, and then you can use ln function. So then what I can write here is that this becomes 4, and then I would write it as 1 over t. But the next one, again, I bring it up. I make it 1 negative 1/2. So the only exponent that you have to be careful about is that when it becomes negative 1. If it becomes negative 1, bring it down again to the denominator and use ln function. For any other exponents, you can use the same formula over and over again, okay? So now what I should do, now I can write my primitive function capital F of x. So then it becomes 1 over 3 over 2 plus 1, then you have 3t to the power of 3 over 2 plus 1. The next one is 4 ln of t. The next one becomes minus 1 over minus a half plus 1 t to the power of minus a half plus 1, and then you have a constant at the end. Oops, again I made this mistake. This is not x, this is t. Yes, so let me just correct it. This is f of t, this is also f of t. And let me simplify that. So capital F of t is equal to this. If you calculate, this becomes 5 over 2, then 2 goes here, multiply by 4, it becomes 4. So it becomes 4 over 5, t to the power of 5 over 2. Then I will have 4 ln of t. Then what is this one? This becomes negative 2, t to the power of 1/2 plus c. Okay? So this is the answer to this problem. Of course, if you want, you can write it back in the form of a square root sign. Okay, and hopefully you know what to do with the next one. So number 5, what we are supposed to do is to simplify this expression first. Here I have to multiply, so x squared times x squared is x to the 4 minus 2x squared plus x squared minus 2, and by the experience that you have gained so far, you know that sooner or later you have to write this in this form. Okay? So let me simplify that. So it becomes x to the 4 minus x squared minus 2, and then I have divided by x to the power of 2/3, and then you know the story. I have to separate them and use that formulas, yes? So it becomes, yes? Simplification, I subtract the powers, so it becomes 10 over 3 minus 6 4 over 3, and then there is nothing to subtract. I bring it up. Now everything is right, so I can start finding my primitive function. So let us do it in my head. So it becomes 3 over 13 x to the power of 13 over 3. I am adding 1 to it, okay? And then it becomes 3 over 7 e to the x to the power of 7 over 3. And then what happens here, it becomes 1 over 3, so it becomes minus 6 x to the power of 1 over 3 plus c. Okay, yeah, these are simple calculations. I want you to fully understand them later, and if I have made any mistakes, please let me know so that I can fix it. So I hope that you don't have any problems how to use these two main formulas. One formula that you already knew from Math 3C, only one new formula that you learned this year, and that is 1 over x. Okay, now I want to continue the lesson. And what happens for other functions? Again, in Math 3C you had this, so let me just write my table but add now new items to it, yes? So here, let us see what happens. This is also a Math 3C problem. So if I have f, and this is my capital F. So do you remember, if I have e to power kx, what is your guess for a primitive function for this? In differentiation, k goes below that, okay? So of course, if I say that the primitive function is something like this, it's not 100% wrong, but it is not 100% correct either, yes? Because if I ask you to differentiate this function, you would say e to power kx, but you have to multiply it by k. But there is no k here. So it is clear what to do. I have to put a 1 over k here to compensate for the k that will come down by differentiation, yes? So that is easy. So if I ask you to differentiate this function, this is a constant, you pull it out, and then you take k e to power kx. But this k that comes down and this k that I intentionally put it there cancel each other, and I will get this function back. Okay, so that is a primitive function for exponential function e to power kx. And you also had something like this in Math 3C. So what happens if I have a to power x? Here a is a positive number and a is not equal to 1, exponential function. So this is equal to 1 over ln of a to power x plus a constant. The reason is that if I differentiate a to power x, if you remember, it becomes the same function, but I have to multiply by the ln of the base. So this is why when it goes to primitive functions, I have to put a factor like this, so that when I differentiate it, this factor that I put there will cancel this factor that comes from differentiation, and then I will left with this one. And of course, it is not hard if I add something more to this. What happens if I have this situation that I have also a k up there? So a to power kx, again for the same story, yes? So it becomes clear that I also have to put an extra k factor in the denominator to cancel both of them. I don't know, for some reason this is not given. So this is also these two are only the ones that you use them. Okay, but I don't need them, so let me clean it. Okay, now let me give you some examples that we can solve using these formulas. if I can find them. These pictures are so small. Yeah. Yeah, so let us put it here somewhere. Yeah, I can make it bigger. Okay, so we want to do the same thing here, but for new functions. So again, a strategy is to expand our table of primitive functions. We learned about those type of functions that I gave you a lot of examples. Now we learn about exponential functions, the primitive function of exponential functions. Very simple, yes? Let us solve them. Just let me solve them because they are easy, and then I want to finalize some part of this lesson today. So the function f of x here is given to be this, and I want to find a primitive function. So it is clear these two functions, I can use this formula. These two functions are the previous formula. I can use the previous formulas, yes? So this becomes very clear. So what I should do, I would say that capital F of x is equal to, here k is 3. If I compare it here, I should write 1 over k, which is 1 over 3. And then I have to repeat the same function. Then I have a factor of 2 multiplied by, here k is minus 2. So 1 over k becomes 1 over minus 2, and then I have to repeat my function. And then this x is the previous formula, so it becomes 1 over 2x to the power of 2, and the primitive function for x is, for 1 is x, and then I have to put a constant c because of this article all. So what I have to do now is to simplify if possible. So this becomes a third e to the power of 3x, and then it becomes positive e to power minus 2x plus a half x squared minus x plus c. So that would be the answer to this problem, yes? Yeah, hopefully this is clear that this minus 2 and minus 2 are cancelled. It becomes positive 1. So this is why you see I have written a positive. Okay, now let us go to the next problem. So here it is clear that one of them is exponential function, by the way. So this is a matrix C problem. Actually, this is the old formula. X to power a is 1 over a plus 1, x to power a plus 1. Okay? But this one is this formula. What is the difference between x to power a and a to power x? Clear. Here the base is variable, the exponent is constant. Here the base is a constant, the exponent is a variable. So if I see here the base is a variable, this exponent is a constant, so it is the previous formula, but this is the new formula. So if I want to find capital F of x of this function, then it becomes 1 over pi plus 1, x to power pi plus 1, but sorry, pi plus 1 should be there. But for the next one, be careful, this is not a power function, this is an exponential function. So I have to write 1 over ln of the base, which is pi, and then I have to repeat the exponential function in front, and then I have a constant. As simple as that. So the only thing is that you need to appreciate the difference between an exponential function and actually a function, a power function. Okay, what can I do for the last one? The last one you have to expand it, multiply it, so that make it simple, and then you can start differentiation. But the idea is actually very clear, yes? So what I do for the next one, first I simplify this. So f of x becomes equal to e to power 2x. I use a squaring pattern to expand this, so it becomes the first one to the power of 2, which becomes 8x. 2 times the first one times the second one. And finally the second one to power 2. I cannot do anything with the rest of it, so I will write it. But I need one more step. One more step is to multiply it inside, so it becomes 10x. Is that understandable? A to power m times m to power n is a to power m plus n. So e to power 2x multiplied e to power 8x, it becomes e to power 2x plus 8x, so it becomes 10x. And then this becomes plus 2e to power 6x, and then I will have e to power 2x, and then I have minus 2x minus 1. Now every one of these functions is a function that I already know how to determine its primitive function. And then I will do that. So capital F of x becomes equal to 1 over 10 e to power 10x. 1 over 6 multiplied by that extra factor of 2, it becomes 1 over 3, but e to power 6x. The other one becomes 1 over 2 e to power 2x. And then the other one is x to power 2 divided by 2, which will cancel the other 2, so it becomes x squared. And the primitive function for 1 is x, and then simply I add a c at the end. So you see that now this is beyond the just guesswork, yes? So we were able to find primitive functions are a little bit more complicated functions. Okay, so that is a primitive function for this. Any questions? Okay, now let us go to the next lesson. The next lesson is actually expanding our table even more. So what I want to write is this. We want to go to trigonometric functions that we learned this year again. So this is f, this is capital F. Now if I write just sine of x, the answer is simple. What do you think would be the answer? Yeah, it is minus cosine. Because if you just simply write cosine, and if you differentiate cosine, it becomes negative sine. But I want to have positive sine. So I have to put a negative sign there to compensate for the one coming from differentiation. So this is simple, okay? But what happens if I have an extra factor inside? So instead of sine x, what is written in the book is sine of a number multiplied by x. If I differentiate this, you know that because of the chain rule, a factor of k will go out. So to compensate for that, I need to multiply it by 1 over k and say cosine kx. And then I put a negative sign here. Now if I ask you differentiate this function, let us do it here. If I differentiate this function, minus 1 over k is a constant. The derivative of cosine is negative sine, but because of the chain rule I have to multiply it by u prime, but u prime is k. Minus sign cancels this minus sign, positive k cancels this positive sign, so what is left exactly is sine of kx. So this formula is correct. And of course we always use this constant of integration at the end, yes? And then if I ask you the same thing for cosine kx, probably you can immediately answer, it becomes this time 1 over k sine kx for the same reason. Okay, for tangent the problem is a little bit more complicated and it is not in the formula sheet and it is not discussed that much in the book. But I will try if we have time today, or otherwise I will talk about that later. It is at the level of your knowledge, it is not above your knowledge. But we still have something to write. If I write something like this, what is your answer? Yes? What can I write on the right-hand column here? So what can I write instead of this question mark? Give me a function whose derivative has this combination. Of course, it depends to your memory. We have studied that function. Okay, so might be you have forgotten. So that function is tangent of x. So be careful here. I am not asking what is a primitive function of tangent. That we don't know now. I'm asking what is a primitive function for 1 over cosine squared x. I'm asking you, give me a function whose derivative is equal to this. And if you go to the previous chapter, we learned about the derivative of tangent. It becomes exactly this combination. And I have to put a constant c at the end. But sometimes you know that there is a trigonometric formula for that. 1 over cosine squared x has also another name, and that is 1 plus tangent square of x. Okay, so what is left to answer, which even though it is not directly addressed in the book, is that what happens if I put tangent of kx here? So what would be the answer? So let us discuss about that later. But let me give you some examples that we can now solve using these formulas. Okay, so let us put it here. I have intentionally made them a little bit harder because if you just want to use the formula, there is nothing fun about that. Okay, so for example, the first one is very, very simple. F of x, let me make the formulas clear for you here. Yes, you have them in front of your eyes now, okay? And then you are supposed to find all primitive functions for this function. Of course, this is very simple because these are just constant numbers, and this one follows this rule, and this one will follow that rule. As simple as that. But the next one, you need to be a little bit more careful, especially for this one, and might be this one. Okay, so let us start doing that. So number one, what should I do? Let me have the formulas. So capital F of x is equal to minus 2 is just my constant. And for this one, I use this formula, but it is easy to see that k is 3 in this case. So 1 over k becomes 1 over 3. So multiplied by 1 over 3. And then cosine turns into a sine. So it becomes sine 3x. And the next one is the same. So I have a 4. But now if I compare this one with that formula, I have a minus sign 1 over k. K in this case is 2. So it becomes multiplied by minus 1 over 2 cosine 2x. That's it. And of course, because it has mentioned all, I have to put this c at the end. And then what I do is just simplifying it a little bit. So it becomes a minus 2/3 sine 3x. And then it becomes minus 2 cosine 2x, and finally plus c. So that is the answer to this problem. Okay? For the second one, what can I do? This is not exactly the formulas that I have, because this is a combination that I don't have it in my table. So it means that I need to use my trigonometric knowledge to simplify it probably, and it will work. Okay? Yeah, I'm not saying that it's always easy, but yeah, you need to have experience. In finding primitive functions could be quite hard. So there are many, you will spend a lot of hours in the university to learn different techniques and tricks for calculating different types, the primitive functions of different category of functions. Okay, so what we can do, I can expand this using a squaring rule. So it becomes the first one to the 2 plus 2 times the first one times the second one plus the second one to the 2. But now this one and that one is a famous identity. It becomes 1. And hopefully you remember this formula when we were studying trigonometry. Do you remember? Sine of double angle, sine of 2u is 2 sine u cosine u. Okay, so instead of this, I can write simply plus sine of 2x. And now everything is ready. I can calculate a primitive function for that. Primitive function for 1 is x. A primitive function for sine 2x is just what we learned today, yes? Sine of kx follows this formula. So k here in this problem is 2, so it becomes minus, because sine is minus 1 over 2 cosine 2x, and then you have a c at the end. Yes, so that is also something that you need to know. So the idea in this problem is exactly this, but it might seem that it is a little bit harder. You need to be a little bit more careful. So if you don't mind, there is no, yeah, we have a little bit of space here still. So number 3, what I do is that f of x is equal to, I use the trigonometric identity, again I expand it. The first one to the 2, so by this I mean this, and minus 2 times the first one times the second one plus the second one to power 2. Okay, but there is no problem here again, so don't look if it is more complicated. I have sine squared of an angle. The name of the angle is not important. What is important is that the same angle repeats itself for sine squared and cosine squared. As soon as I have this combination, this becomes equal to 1. Yes? So this might be a little bit tricky, but of course if you are experienced in trigonometry, I don't think it should be. Again, this combination is similar to this. Yes? 2 times a sine of an angle, cosine of an angle. If I take this to be u in my head, then it becomes 2 sine u cosine u, which is exactly this one. So according to this formula, I can write it as sine of double angle. So double u, 2 times u becomes 2 times 3x over 4. So it becomes 3x over 2. So then it becomes minus sine 3x over 2. But 3x over 2 means 3 over 2 times x. As simple as that. So you need to understand that even though it seems a little bit complicated, but just expanding it and using 2 trigonometric formulas, you can write it in more manageable way. And now if I ask you what is a primitive function, it is simple. Primitive function of 1 is x. The primitive function for the second part, what you need to do, you need to compare this with this formula in the formula sheet, yes? But be careful here, this will play the role of k. I have a minus sign here, and minus sign is coming from the formula, so it becomes minus 1 over k, k is 3 over 2, and then cosine k, 3 over 2, x, and then of course a constant of integration. But let me simplify this a little bit. So it becomes x, minus and minus are gone, 1 over 3 over 2 is nothing except 2/3, and then I have cosine 3 over 2x, and at the end I will have a constant c. So this is this expression. I will just solve because I have to rush to school. I have to be there in 1 hour again. So I will solve that problem. This somehow is given as level 3 problem, a level 3 problem in the book. So I will tell you, if you don't know the trick, might be you will face some problems here, because the reason is that this 2 is the exponent. If I ask you sine 2x, that's no big deal because you can immediately use the formula. But what happens for this, you need to know the trick. So I might give probably this, I want you to pay extra attention, because if you don't know the trick, you will not be able to solve this simple problem, okay? So f of x is equal to sine squared x. So what I do is this. So what is the number? The number is 4. So let me write it in front of our eyes. So f of x is equal to sine to the power of 2x. Do you have any idea what to do? So the only trigonometric functions that you can find as primitive functions are of these type, where you have some k but you don't have any powers. So if you have a combination or one of them, then you can do the problem. But here, unfortunately, there is a power 2 up there. This could this could be quite hard if you have totally forgotten about trigonometric formulas. Okay, so do you think at least which formula would be helpful? You can just tell it to me and name it, then I will write it for you. Okay, so double angle formula for cosine. So cosine 2x, it has three versions. So one version is useful. If you go to the formula sheet, you will find this. This is one of the formulas of the double angle formula. So why this is useful? Because first of all, this is exactly what I want to talk about. And what is left for me are these two functions. If I ask you, do you know a primitive function for this? I would say yes. Do you know a primitive function for this? I would say yes. So it means that in principle, I should be able to find a primitive function for this using these two. Yes? But I need to do some minor changes. So I will take this to the left, make it positive, and move it to the right, make it negative. Okay, so it becomes 2 sine to the power of 2x. Then it becomes 1 minus cosine 2x. But of course, what I want to have a coefficient of 1, but this coefficient of 2. So I divide by 2. So then it becomes sine to the power of 2x is equal to. There are two terms to divide by 2. One, the first one, and the second one. Okay, now everything is ready. So what I do, you need to write this in this form first. It becomes 1 over 2 minus 1 over 2 cosine 2x. Now, if I ask you, can you calculate the primitive function for capital F? I would say yes. Because if you tell me what is a primitive function for this constant, this is just that constant multiplied by x. And then this constant goes away, and I concentrate on the primitive function of cosine of 2x. But cosine of 2x is exactly the right combination. But here, of course, k would be 2. Then it becomes 1 over 2 sine of 2x. That's it. So then it becomes 1 over 2 sine 2x. So remember, this 1 over 2 is exactly this one. Another 1 over 2 comes in because of the formula and then are supposed to be multiplied. And then I have a constant c at the end. So then what happens is that capital F of x is equal to 1 over 2 x minus 1 over 4 sine 2x, and then I have a capital C at the end. Yes, so that would be the set of all primitive functions for this function. So this is technical. Remember, I have seen it in the book. This is why I am mentioning it here. Okay, so let us finally, I have still a little bit of time, very short, but let me do it. Number 5, f of x is equal to 3 sine squared plus 4 cosine squared. I think the idea is clear. 3 sine squared plus 4 cosine squared. Okay? Yeah, it is easy to understand because 3 sine squared, instead of 4 cosine squared, I will write it 3 sine cosine squared plus another cosine squared x. Why this is useful? Because now I can factor a 3 out here. It becomes sine squared x plus cosine squared x, and then I have cosine squared x. But the first one is just simply 1. This is a famous trigonometric identity. I will face the same problem again. I can solve it in two different ways, but let me just tell you that there is another version for cosine 2x, which is 2 cosine 2x minus 1. You see, this version writes this in terms of sine. This version writes this in terms of cosine because cosine appears here. That's easy. Of course, you can write it as 1 minus sine squared. Then it becomes 4 minus sine squared. And then you can use the same trick as I did before for sine. It doesn't matter. Both of them are correct. I intentionally want to use this so that you can know both of them. Okay, so what happens? This becomes 2 cosine squared x is equal to 1 plus cosine 2x. And I divide by 2 again as before. It becomes 1 over 2 plus 1 over 2 cosine 2x. Okay, so then it becomes equal to 3 plus 1 over 2 plus 1 over 2 cosine 2x, and then it becomes 5 over 2 plus 1 over 2 cosine 2x. And then I know what to do. So a primitive function of 5 over 2 is simply 5 over 2x. And the other one is 1 over 2, again 1 over 2 sine 2x plus c. And then finally, capital F of x is equal to 5 over 2x plus 1 over 4 sine 2x plus the constant c. So that is also something I want you to know. Okay, so we stop here and end